Hey, good morning. Today we're going to look at solving nonlinear systems. And so we have already reviewed and talked about how to solve systems of linear equations. And we can do that graphically. You can do that by using a method called substitution and another method called elimination. And so today we're going to look at what happens if you have equations that are nonlinear, such as quadratics or circles or square roots, or anything else that's not a straight line. And then, of course, you can mix them with straight lines. And so today we're going to look at parabolas, which is a quadratic equation, and lines, which is a linear equation. And we can determine where it intersects, if it even intersects at all. We can look at circles and lines. And we can then find the points of intersection. Maybe it's 1 point, maybe it's 2, maybe it's none. And then we can look at maybe a parabola and a circle. I mean, these things can get really creative. And so you can figure out the points of intersection if they have one. And some of these have 4 intersections. And then we even look at, sometimes we have ellipse, which are just funny looking equations. And then we've got these hyperbolas, and we can figure out the 4 points of intersection. Sometimes you have a parabola and you have another parabola, and so you can figure out the points of intersection. So we're just going to take all sorts of different shapes today, and we're going to figure out their intersections. Okay, so one may be linear and one may be quadratic, or maybe they intersect nowhere. So we're going to do this today algebraically, and then I'll show you guys with technology how to do this graphically on the calculator, which is an easier way. It's just an easy way to check it, but you have to know how to do this algebraically. Got to be able to show your work because there's going to be some times in your life where you're not going to have a calculator when you guys take state tests in the future. And so you have to learn how to do this mathematically. Plus, it makes it a little more easier to understand how this stuff works. Okay, so the first thing I need to talk about is an equation of a circle. We haven't really talked about circles. You do in Math 3. But a circle, the equation for it is x minus h squared plus y minus k squared. And I just want you guys to know what that equation is, equals r squared. I just want you to recognize that equation. So if you see it, you know, oh, that's an equation of a circle. So at least you know what shape you're dealing with. And of course, the center is going to be whatever that hk value is. And the radius, which is the distance from the center to the side of the circle, is whatever the r is. And so I just want you to be able to recognize a center because we may have to graph one day by hand, and so you'll have to know how to graph that. So here's an example. If they give you a center of 3, -1, and a radius of 2, you should be able to now write an equation for that circle using the formula above. So I'm going to take my center and my radius and simply plug it into that equation. So it would be x minus the h value, which is 3, squared, plus y minus the k value, which is -1. So that turns that into a +1 squared. And my radius of 2 squared gives me a 4. And so that would be the equation of the circle with center at 3, -1 and a radius of 2. Then, of course, I could give you an equation of a circle, and you should be able to tell me what the center is and what the radius is equal to. So you might have to graph this one day without a calculator, and so therefore you're going to have to figure out what the center is. So my center would be, what do you think? -4, +4. Why is it a -4? Because the formula says minus and this is a plus, and so you do the opposite. This is a minus, but we're going to do the opposite, which is a plus, and that's only because the formula has x minus h and y minus k. So think a little bit there. My radius is going to be the square root of 81. So what is the square root of 81? That's right, it's 9. Okay, so the square root of 81 is 9. So hopefully you're able to pull the point of the center point out of the equation and then take the square root of that r to get your radius. All right, so again, you may just need to know that. They may ask you questions about your center and your radius, and also you need to know that, so if you have to overgraph by hand. which of course on any state test you won't have to ever graph by hand, but if you're given multiple choice, you should be able to look at your answer choices and figure out which one has the correct center and which one has the correct radius. I'm going to do one more where you have to write the find the equation. Writing the equation's easy peasy. All right, so in this example, my center would be what? If you said 1, 0, you are correct. And therefore, my radius is what? You said 5, you are correct. All right, so again, it looks like a -1, but because the formula says x minus h, my h is simply 1. This one doesn't have anything with it, so it's a 0. And then we know the square root of 25 is 5. All right, so those are circles. Why do I need to know about circles? Because if you have to graph them when we start doing inequalities of nonlinear systems, and that way also when you're given a system of equations, you can tell me what shapes you're looking at. Because I may just ask you, what two shapes are we going to be dealing with? A parabola in a circle or a line in a circle? Okay, so of course you need to know all your different shapes, your different functions, things like that. So we're going to talk about the two ways we can solve nonlinear systems. Of course, we can graph, which we're not graphing today. We're going to use substitution, which we have already reviewed, and we can use elimination. So the trick is going to be, which method should I use? Which method is going to be the best? Well, if they're lined up, you're going to use elimination. So in other words, if you're I don't know why I keep drawing while I'm drawing here. If the x's are on top of each other, the y's are on top of each other, then you're going to use elimination. And you'll use substitution if you have an x equals that we can box up or a y equals that we can box up. So that's how I would look at it. If I looked at a problem, I would say, can I box anything up? If not, are they lined up? Okay. So let's take a look at an example. We have x plus y equals 1, and we have y equals x squared minus 5. So do you know what types of functions these are? This first one is a linear function because that's in standard form, ax plus by equals c. The next one is a quadratic because of the x squared. So it's just very helpful to know what you're working with. So I obviously have a quadratic that opens up. Does anybody know how and why I know that that thing opens up? If you said it's because a is positive, you are absolutely correct. And then I have a line that has a negative slope, and I know that because if I were to solve that thing for y, I'd get y equals negative x plus 1, so it's got a negative slope. So it possibly looks like this, where it could have two solutions. Or maybe it's going to touch at one point. Oops, I missed my parabola, but if I make a big dot there and pretend it sits right there like that, then I could say it's got one solution. Or maybe my parabola opens up and my graph is under, that line is under my parabola. So maybe it has no solution. I don't know which one is my answer, unless I pull up Desmos and I graph it and then I could see. But we're not going to do it that way. We're going to solve this algebraically by using substitution or elimination. So if you take a look, do you have an x equals or a y equals we can put a box around? The answer to that question is yes. So I have y equals x squared minus 5. So I'm going to use substitution. I'm going to take that box and I'm going to plug it in for that y using substitution. So my equation is going to be x plus x squared minus 5 equals 1. And so what we have here is a quadratic. And how do we solve quadratics? We can factor it, we can use the quadratic formula, or we can complete the square. I leave that completely up to you. You pick one of the three methods, but you do have three choices there. So I need to set this thing equal to 0 if I'm choosing to factor it or to use the quadratic formula. So I'm going to say, and I got to put it in standard form too. So x squared has to come first, plus my x, and when I move my 1 over, this gives me negative 6. You with me? All right, then I think I can factor this. So what times what gives me 6? So the method I'm choosing is I'm going to factor. So I am going to set up my two houses. I got my x and my x. What times what gives me 6? And the same two numbers are going to have to give me a 1. So you can list your factors of 6, 1 and 6, 2 and 3. So 2 and 3 would be my winning answers here. Positive 3 and a negative 2 would give me a positive 1 for that middle term. So we're just factoring. My leading coefficient, I don't have one. I do, it's an understood 1, but I don't have to divide by it because I'll end up with the same thing. Split your factors up so you have an x of negative 3 and an x of positive 2. All right, so remember when you're using substitution, you think you're done, but you're not. All this tells me right now is I have an ordered pair with a x value of negative 3. I need to go back and find my y. And then I have another point with an x value of 2, but I have to go back and find my y. Do you remember how to go back and find your other side of your ordered pair? That's right, we're going to take these and plug it into the boxed equation, one at a time. So let's first plug in negative 3. Don't forget your parentheses, so negative 3 squared minus 5, that's 9 minus 5 is 4. So when I plugged in negative 3, I got 4. Now let's take the 2 and plug the 2 in. So now I have 2 squared minus 5. 2 squared is 4. 4 minus 5 is negative 1. So I have two solutions. I have negative 3 comma 4 and I have 2 comma negative 1. So I have two solutions here, which means my graph must look like this. If I were to graph it on Desmos or my calculator, which we're not going to. You can do that to check your work, but you need to show me your algebra behind your answers. It's good practice for you with solving equations, and it's good practice with you for dealing with quadratics if you have to factor or use the quadratic formula or whatnot. All right, so let's take a look at another example. X squared plus y squared equals 9, and y equals x plus 3. So what I have here is a circle centered at 0, 0. So this is a circle centered at 0, 0, and the radius is 3, because you have to take the square root of that 9. And then y equals x plus 3, that's a linear equation. So I have a circle and a line. Do they intersect twice? I don't know. Do they intersect at one point? I don't know. Maybe they don't intersect at all. I have no clue. I could pull up a calculator and see, but I'm going to solve this algebraically. So what method do you think I should use? Substitution or elimination? If you said substitution, I'm with you. You can box up the x plus 3, and I'm going to black out the y. You notice I'm leaving the squared there. I'm not getting rid of the y squared, just the y. So I'm going to create my equation, x squared plus parentheses x plus 3 goes in for that y, but I still have that squared. Got to put that squared there. Equals 9. Again, we like to solve these things algebraically because it helps us review all sorts of algebra stuff we have learned in the past few years, such as the box method or the FOIL method. Oops, I don't want to do that. I want to highlight. So if you notice this x plus 3 squared, I can box this or I can FOIL this. And you guys know me, I like the box method. Well, if I choose the right writing utensil here. So I'm going to say x plus 3 squared means x plus 3 times x plus 3, right? So I get x squared, 3x, 3x, and 9. So I get x squared plus 6x plus 9. And there is a little trick there. You could have squared your x, which gives you x squared, squared your 3, which gives you 9, and then when you multiply 3 times x, you get 3x, and then you double that, multiply it by 2, and you get 6x. So that's a little trick there. Square the first, square the last, and double the middle. All right, because this is a quadratic, I must set it equal to 0. And then I can factor it or use the quadratic formula or complete the square, whatever method you want to use. And I already know you guys don't like completing the square. Poor thing. It's very easy to use. All right, so when I combine, I get 2x squared plus 6x. And then when I move my 9 over, I get 9 take away 9, which is 0. So I'm going to factor this. Quadratic formula doesn't need to be done. Completing the square doesn't need to be done because it looks like it's got a greatest common factor. What's my greatest common factor? 2x, absolutely. So when I divide each of these by 2x, I get x plus 3. So now that I'm done factoring, I'm going to split, set each side equal to 0. So on the left side, when I divide by 2, I get x equals 0. On the right side, when I move my 3, I get x equals negative 3. Remember, you're not done. You're using substitution, so you have an ordered pair of 0, because that's my x value. I don't know my y. And my other ordered pair is negative 3, comma, I don't know yet. I got to find it. How do I find it? That's right. You got to plug your answers into the boxed equation. So this first one, when I plug in 0, I get 0 plus 3, which is 3. Now when I plug in my negative 3, I get negative 3 plus 3. What's negative 3 plus 3? 0. So I have two solutions. So my line and my circle cross at 0, 3 and negative 3, 0. I know what you guys are thinking. That's so much work. Why can't we just plug it into the calculator and get an answer? Because you need to learn algebra. You need to know how to FOIL. You need to know how to solve by factoring. You need to know how to factor. So these things incorporate all those different ideas that we have learned in the past. It gives you good practice. All right, so we have done 2 substitution problems. Let's try elimination. So example number 3. I think it's struggling here. Or maybe I'm struggling. All right, so I have x squared plus 2y squared equals 11. And I have 3x squared minus 2y squared equals 25. Now, these are not circles. This is an ellipse and some kind of hyperbola. I don't even know if that's really called a hyperbola because usually our hyperbolas are rational functions. Maybe I should look that up, huh? Maybe you should look that up. Extra credit. Tell me what the name of these two functions are. I know the first one's an ellipse. The second one, I'm going to go on a stretch here and say it's a hyperbola, but I'm not 100% sure. But it looks like this. And so maybe it has 4 solutions. Maybe it's got no solutions. Maybe it has 2 solutions if they only touch twice. So we're going to figure this out. Again, what method should you use? Well, they're lined up. You see the x squareds are lined up. The y squareds are lined up, and my constants are lined up. So I'm definitely going to use elimination here. So remember, with elimination, you want to look for opposites. Do you see any opposites? I do. My y squareds are opposites. So because I already have opposites, you're going to add the equations. If you didn't have opposites, you'd first have to make opposites, then you would add the equations. All right, so when I add, I get 1x squared plus 3x squared is 4x squared. Almost gave away the answer there. Equals, the opposites cancel. So now I'm at 11 plus 25 is 36. Divide by 4. X squared equals 9. To get rid of a squared, you're going to take the square root, which we know the square root of 9 is 3. But we need both the positive and the negative 3. So be careful here. When you take the square root, make sure you give both positive and negative answers. Okay. So a little note there. Make sure when you're taking the square root, when you're solving these things, you need both answers, because if you don't, then you're only getting one ordered pair answer. So I have an x of 3. And I have an x of negative 3. And now I just got to figure out what my y's are. This problem's going to get a little crazy. So I'm going to take my 3's, and it doesn't matter which equation I plug it into. I can plug it into the top one or the bottom one. I'm just going to go to the top. So the x squared I'm going to replace with a 3. So this becomes 3 squared plus 2y squared equals 11. So I get 9 plus 2y squared equals 11 minus 9. 2y squared equals 2. Divide by 2, y squared equals 1. How do you take the square off? Square root. So you get y equals plus or minus 1. Again, remember when you are taking these square roots, that you do both, the plus and the minus. All right, so that tells me when I had a 3, I had a plus minus 1. So I have a 3 and a 1, and I had a 3 and a negative 1. Cool, huh? So what happens when I plug in a negative 3? Well, watch this. If I take and I put in a negative 3 in my parentheses, what's negative 3 squared? Positive 9. And then the problem looks exactly the same because you are squaring that negative 3. Gives me a positive 9. So my answer is going to be the exact same thing. I'm going to get a positive 1. And when x is negative 3, I get a negative 1. That's how you're going to get your 4 solutions. The question comes up, can I write plus minus 3 comma plus minus 1? And I guess the answer would have to be yes, because there would be your 4 answers. Positive 3, positive 1, negative 3, negative 1, negative 3, positive 1. So yeah, you could write it like that. That would be okay too. All right, so that one was elimination with 4 solutions. Be careful there when you go back and plug it in and you take a square root, do the plus and the minus. All right, I have one for you to try. So your turn. I want you to try y equals x plus 3 and xy equals negative 2. And then that one's a substitution problem, okay? So that's your little hint, use substitution. Number 2, I want you to try 2x squared plus 3y squared equals 30. And 3x squared minus 2y squared equals 19. Your hint there is elimination. And you're going to have to make opposites because right now I don't see any opposites. There's some close looking opposites in there, so make them opposites by multiplying. And then once you have your opposites, you can solve. So I want you guys to try those 2 problems. You'll write them out, and then you will upload that in your Google Classroom and send it to me. I'm trying to see if I wanted to add any others. Let me add one more. Let's do there's so many good ones. I'm having a hard time deciding on which one I want to do. All right, try y equals 5x minus 20 and y equals x squared minus 5x plus 5. All right, so use substitution or elimination. Depends on how it's fixed up and ready for you to go. Do just these 3 problems. Think about these examples we just did. Go back and look at them. Your elimination problems are a little in depth there, but you can handle it. Substitution, box it up, plug it in. Sometimes you have to box, do the box method. Sometimes you have to factor. Just look at the problem carefully, set them equal to 0, and solve them accordingly. All right, and so what I need you to do is do these 3 problems. You need to show your work. Can you use the calculator to check it? Yeah, pull up Desmos, type those equations in, and see if you get the same answers. But I really need you guys to practice these algebraically to help you with your solving in your algebra, because sometimes we're a little sticky in those areas. All right, so upload that. Let me know if you guys have any questions, and I will see you guys soon. Bye.